Cramer's rule tell us that if you have this equation a11 x1 plus a12 x2 plus a13 x3 is equal to b1, a21 x1 plus a22 x2 plus a23 x3 is equal to b2, a31 x1 plus a31 x2 plus a33 x3 is equal to b3. Now you have this equation of matrices a11. Okay, so you can write, before you write this one, let's say if you talk about determinant of matrix, if you add to one column a constant multiple of another column, determinant does not change. Similarly, if you have a row, add constant multiple of another row to this row, the determinant will not change. Okay, that means if I have a11, a12, a21, a31, and I add this some constant times c1 times some constant times a12 plus some constant times a22 plus some constant times a32. Then you have a12, a22, a32. Then you have a13, a32, a23, a33. You have this determinant will be same as determinant equation. This is same as determinant of A. Similarly, you can add a constant multiple of one row to another row. The determinant does not change. So I can say that I will add so what I have here is a simple matrix. Okay, so what I can do, I write this equation now as a11 plus a12. I divide this equation by x1. So a12 x2 by x1 plus a13 x3 by x1 is equal to b1 by x1. I can rewrite this equation in this fashion. And in the second equation, I will write a21 plus, I will divide this by x2. So a21 x1 by x2. Oh, sorry. Okay, so I will simply write this also divided by x1. So a22 x2 by x1. So what essentially I am trying to do is, okay, this may be enough for us to get an idea as to what I am going to do. So I have determinant of a11, a12, a13, a21, a22, a23, a31, a32, a33. Let's say this is my determinant of A. Now, what I will do, this determinant is same as determinant of a11 plus 1 by x1 times this. 1 by x1 times this. So that means a11 plus 1 by x1 times a12 and plus let me call this as x2 by x1 times a12 plus x3 by x1 times a13. So for the first column, I am multiplying x2 by x1 times second column, x3 by x1 times third column. Okay? And then remaining things I will leave as such, a12, a13. Similarly, here I have a21 plus x2 by x1 times a22 plus x3 by x1 times a23 a22 a23 and finally a31 plus x2 by x1 times a23 plus x3 by x1 times a33 a23 that a32 a32 a32. So this determinant is same as the determinant. Do you understand that? Because I have added to this column x2 by x1 times this column plus x3 by x1 times this column. What is the advantage of doing this is this quantity now I can write it as b by x1. Correct? So this is equal to, I may write this as, so this gives me determinant of A is equal to determinant of b by x1, b1 by x1, b2 by x1, b3 by x1, and a12, a13, a22, a23, a32. So this is equal to now you can write down mod A is equal to 1 over x1 times b1, b2, b3, a12, a22, a32, a13, a23, a32. So now you can get x1 as this determinant. So I can write it x1 is equal to 1 by determinant of A, the determinant of this object. So if I replace first column by b1, b2, b3, take the determinant, divide it by the determinant of A, I will get x1. I will get x2 along the similar construction, 1 by determinant of A into a11, a21, a31. In the second column, I put b1, b2, b3, and a13, a23, a23. So I find out the determinant of this matrix where b1, b2, b3 is replaced. In the second column, I get x2 and x3. x3 I will get, again 1 by determinant of A, a11, a12, b1, a21, a22, b2, a31, a32, b3. And then calculate this determinant divided by the determinant of A, we get x1, x2. This way of solving the algebraic equation is called Cramer's rule. So you can see that you have to actually evaluate 4 determinants for a 3 unknowns. You have to evaluate this determinant, you have to evaluate this determinant, and you have to evaluate this determinant. Once again, when it comes to evaluating the determinants, as I pointed out yesterday, it's a very time-consuming job on a computer. I told you yesterday, 50 by 50 matrix, you want to calculate determinant, you will require huge time. So we cannot take the determinant evaluation as a simple thing in a computer. So we should, even though this is a nice algorithm, again, we can solve some problems of 3 by 3 matrices, and exercise problems can be done, but it's also not a very good method for solving the simultaneous linear equations on a computer. Okay, the determinant problem can be understood in the following way. Even though I told you that we have the Laplace expansion, there is a Laplace expansion is not very